Welcome, public inventors. This is an update video. I'd just like to explain some of the things that have been happening. If you watched my last video, you know that I had the octahedral tetrahedral robot walking in a very limited sense, in the sense that it could turn to the left. What I did after that was I had a lecture at Tech Shop where I invited some people to make comments and help me think about how to use the system, and a number of interesting things came out of that. In particular, the discovery that this shape might make a better robot. There is a structure called the tetrahelix, which is different than putting octahedras and tetrahedras together, in which simple tetrahedras make a mast, which happens to be a triple helix. I'm sorry, I don't have a long one put together right now. Anyway, this could decrease the number of actuators needed significantly in the robot. So my goal is to build this shape, and furthermore to make it capable of walking in a way that the other one was not. Of course, a complete tetrahedral system requires a slightly different geometry in the turret joint, and so I've spent some time doing the 3D printing of the turret joint to accept that geometry. An additional thing that I have done is shifted to the use of the Arduino Mega, which has enough output pins that in theory I can control all of the actuators in this structure, which I call it the 3-tet robot, because it is 3 tetrahedra rather than an octahedra and tetrahedra put together. And I believe that this structure will certainly be able to walk as an inchworm, for example. I've made some progress in the actual construction of this, which is here. This is a 2 tetrahedron robot, and I have the parts necessary to build the 3 tetrahedron robot. And my idea is that the Arduino Mega and the other electronics will go in the center here, as they did in my previous robot. However, I've had a heck of a time getting all of that working, and I've spent a lot of time working on electronics. I attempted to build an Arduino Mega shield with a Pololu motor controller on here because I really want to get the ability to control 12 actuators using 6 of these dual motor controllers onto a single Arduino, so that I can perform any walking gait I want without having to coordinate multiple Arduinos. I found this very difficult to solder, and in fact somehow I shorted 5 volts to ground when I was doing this, so it wasn't particularly effective. Additionally, I wasted a lot of time, although I suppose I learned a lot, using EagleCAD trying to design the printed circuit board for this system. This breadboard is actually working, and I also spent some time getting Bluetooth working. This is a little SparkFun Blue Smurf Bluetooth system, so that in the future when I give a demo I won't have to have a cable hooked up to my Mac, which is going to be very important. Unfortunately, as you can see, as always happens with breadboarding, you have a rat's nest, and this is just one motor controller, which allows me to control 2 actuators. So what I intend to do is to put multiple breadboards together and try to get them to fit inside the robot, so that I can actually have 6 motor controllers. I may then go on to actually publish a printed circuit board design and have a printed circuit board design, because I think many people would like to have as many as 12 1-amp motor controllers controlled by a single Arduino. So I think it would be a reusable board, but I've never done printed circuit board design before. So I've been using Eagle software CAD to do that, and it's got quite a steep learning curve, I have to say. Nonetheless, my goal is to have a structure like this one, only larger, walking as soon as possible. So that's what I've been doing. As always, if you're interested in this project and helping, everything we do is open source at Public Invention. Please send me email. I would love to get other people involved in the project. Thank you.